Welcome to Autism Mathematics. I am on the series Logarithm. In this video, I'm going to take you through the use of change of base to solve logarithm equation. So let's start. If log to the base 2 of x squared plus 1 minus log to the base 4 x squared is equal to 1, we have to find x. Now we are using change of base. Remember, if you have log x to the base a and we want to change the base to p, now it is log x to the base b over log a to the base b. And so we want to change this. So let's change 4 to base 2. So we have log to the base 4 x squared. Now we are going to have log to the base 2 x squared over log to the base 4 2. And this is 2 log x to the base 2 over, and then this we can write it as log to the base 2 squared. So we can write it as log 2 log x to the base 2 over 2 log 2 to the base 2. Now this will give you 1. These 2 will cancel. So we have log x. So the equation now becomes log to the base 2 x squared plus 1 minus log x to the base 2 is equal to 1. So let's apply the rules. So we have log to the base 2 x squared plus 1 over x, because they are subtracting, is equal to 1. So this implies that by definition x squared plus 1 on x will be equal to 2. So this implies that x squared plus 1 is equal to 2x. So x squared minus 2x plus 1 is equal to 0. And this is a perfect square. To factorize it, we have x minus 1. So factorizing, we have x squared minus x plus 1 is equal to 0. So x into bracket x minus 1 plus or minus 1 x minus 1 is equal to 0. So x minus 1 is equal to 0. So this is a perfect square. So x minus 1 is equal to 0 implies x is equal to 1. So therefore, in each case we are going to get 1. Therefore, x is equal to 1 twice, because it is a perfect square. Yes. Let's take another question on change of base. Solve the equation log x to the base 3 minus 3 log 3 to the base x is equal to 2. I want you to pause the video and then try it first. Okay. So let's see how you go through. So let's change this to base 3, because this is easier to change. So log 3 base x becomes, the new base will be log 3 to the base 3 on log x to the base 3. So which is 1 over log x to the base 3. So in place of this, put it there. Of the equation becomes log x to the base 3 minus 3 times 1 on log x to the base 3, which is equal to 2. So we are going to, when you cross multiply, we are going to have log to the base 3x all squared minus 3 is equal to 2 log x to the base 3. So we can bring this one to this side. So we have log x to the base 3 all squared minus 2 log x to the base 3 minus 3 is equal to 0. So let AVP A be equal to log x to the base 3. So we are going to have a squared minus 2a minus 3 is equal to 0. We then factorize. 2 factors of 3, 2 of them when you add you get minus 2, and then when you multiply you get minus 1. So you have minus 3 and then 1. So this implies that a squared minus 3a plus a minus 3 is equal to 0. So we are going to have a into bracket a minus 3 plus 1 into bracket a minus 3 is equal to 0. So we have a minus 3 a plus 1 is equal to 0. So we have a minus 3 is equal to 0 implies that a is equal to 3, and then a plus 1 is equal to 0 implies that a is equal to minus 1. Okay, we said that a is equal to log x to the base 3. So for each value of a, we are going to find x. So for a is equal to minus 1, it implies that log x to the base 3 is equal to minus 1. So by definition, x will be 3 raised to the power minus 1, which is 1/3. For a is equal to 3, log x to the base 3 is equal to 3. This implies that by definition of log, x will be 3 raised to the power 3, which is 27. So therefore x is equal to 1 on 3 and then 27. Viewers, thank you very much for watching this video. I'm grateful to have you stay with me throughout this video. If you are watching me for the first time and you have not subscribed, kindly click on the subscribe button. You can also turn on your notification button so that anytime I drop a video, you can easily get it. You can also give your comment.